All right, so this is going to be the first optimization problem that we're going to work on. Basically, this is very basic. It's just wanting us to find a couple numbers. So we'll find two numbers whose sum is 40, and then their product is going to be a maximum. All right, so we have two things going on here. First off, we have a sum and a product. So we're going to work with our sum equation first. And the sum equation would be x plus y equals 40. All right, because we already know what the sum is supposed to be equal to. The other one is going to be our product equation. Now, the product, we don't know what the product is, but we do know we want to maximize it, right? So we're going to come up with this function, x times y. Remember, I'm using x and y because I don't know these two numbers. They could be equal to each other. They could be different. I'm not 100% sure yet. We're going to try and figure that out. All right, now, I'm not going to take the derivative of my product equation just yet. All right, so that f of x equals x times y, I'm not going to work with that. I'm going to come over here to my sum equation, and I can solve for either x or y. Doesn't really matter. I'm going to solve for y. And now I'm going to use that, and I'm going to come over here to my product equation and substitute that in to y. Now, this is much better. It's one variable. We can go ahead and take the derivative of this right now. Instead, what I'm going to do, I'm going to go ahead and distribute through. I'm going to get this function to be 40x minus x squared. All right, now we can take the derivative. The only reason we're taking a derivative is because we want to maximize something. Remember, if we want to find maximization or minimize or anything like that, we got to figure out where our function changes direction. So in this case, since we want to max, we want it to increase, go to a slope of 0, and then decrease, right? So we got to figure out where that slope of 0 occurs. So in order to do that, take your derivative. Take that derivative equation, figure out where it is equal to 0. Figure out where that slope is equal to 0. You're going to find out 2x is equal to 40, and then x is equal to 20. Now, the one thing that we always want to do is we want to test that out. We want to make sure. So I know at 20, I get a slope of 0. What happens at 10? What happens at 30? So I'm going to take 10, plug it into my derivative. I'm going to get a positive value. I'm going to take 30, plug it into my derivative, get a negative value. So you can definitely see that 20 does maximize it. All right, so now we know that x is equal to 20. Now all we have to do is find our other value. And y is also equal to 20. So there's a maximization or an optimization problem using maximization with our derivatives, but using our two equations simultaneously.